What theorem did we learn yesterday? Triangular theorem? What's that? Midsegment. What's a midsegment do? Or what is a midsegment? How about that first? What is a midsegment? Close. Close. So a midsegment is a segment that touches the midpoints of two sides of our triangle. And then what is the midpoint relation? What is the relationship between those two? The midsegment is what in relation to the third side? It is half, and it's also parallel. Today, we're going to get a couple of more theorems. We're going to get a perpendicular bisector. What does perpendicular mean? Intersects at what kind of angle? Right angle. Perpendicular lines intersect at a right angle. And what's it mean to be a bisector? Cut in half. So our perpendicular bisector theorem, if a point lies on a perpendicular bisector, so a line that's intersecting at 90 degrees and cuts another segment in half, then it is equidistant from the endpoints of the segment. What's it mean to be equidistant? Yeah, it's the same distance across, which would make those two segments what? Congruent. Make our two segments congruent. So if a point lies on the perpendicular bisector, it is equidistant from the endpoint. So if CD is perpendicular to AD, or AB, and AD is equal to BD, so our lines are perpendicular. How do we know they're perpendicular? Gives us the right angle. How do we know AD is equal to BD? But why? How do we know it's a bisector? Yeah, the two are congruent. So as long as that is true, AC is congruent to BC. AC is congruent to BC. So on our diagram, it will be almost the ends over here. It's kind of using side angle side. If we really think about it, same side angle side. So why would that segment be congruent? It's a reflexive POC, it's a shared side. Those two are already congruent because they tell us, and both of those would be 90-degree angles. So the theorem is already reinforcing what we know and what we learned from last unit. So as long as it's a perpendicular bisector and that bottom segment AB has been bisected by showing that we've got two congruent segments, we can say the hypotenuses are also congruent. And then on the other side, we've got the converse. How do we know it's a converse? What is a converse? From unit 2, little way back flashback from unit 2, what's the converse? You flip it. You take your hypotenuse and your conclusion and you flip it. Did I get it right? You did, man. Okay, so if a point is equidistant from the endpoints, now we're looking at what we proved on the last one using our theorem. Now this is true. If this is true, if CA is equal to CB, then we can conclude CD is perpendicular to AB. Where's my little box? Oh, Peter. So we can conclude line CD is perpendicular to segment AB. And what else can we conclude? If it's the converse of the first one. Yep, AD is congruent to BD. So it just takes the given on the first theorem and flips it with the conclusion of the first theorem. So the first theorem told us if we got perpendicular lines and it's been bisected, then those hypotenuses are going to be congruent. But when we use the converse, we're saying, hey, if the hypotenuse is congruent, then they have to be perpendicular and it has to be bisected. Y'all ready to do some math with it? No? That's too bad. TIF. Find the value of x. Okay, so we've got a right angle and it's been bisected. So what do we know about those two values? They're going to be congruent. So we know that each one of our hypotenuses must be congruent. What's wrong, brother? Okay. So how can I set up a congruent relationship?
My hands up.
What you got?
You do 7x plus 24 equals 13x minus 48.
Yeah, man, you just set them equal to each other. Because if they're congruent, they are equal. What you want to do first?
Add 48.
You're going to add 48? What's our ultimate goal when solving? Isolate our variable. Absolutely. So we add 48 to both sides. So we get 7x plus 72. Is it 72?
Yeah.
13x. Is our variable isolated yet?
Yeah.
No. We need to move.
Minus 7x.
We're going to subtract 7x from both sides. We've got to get it by itself. Yes. So we subtract 7x from both sides. So we get 72 equals 6x. Is our variable by itself yet? No. It's still got that 6 attached to it. Get rid of that 6. Divide it. Good. So 72 divided by 6?
13. 13? 12. It ain't 12? Yeah, man. Yeah, it is 12.
So 12 equals x. It is indeed 12. Number 2, find the value of x. This time it looks like we're using the converse. Because they gave us congruent hypotenuses. They told us this was a perpendicular bisector. So with all that information, what do we know about those two bottom segments? They are congruent. What has to equal 90 degrees? Yes, the angle is 90 degrees, correct. But we're not talking about the angle here. But yes, if we were looking for the angle and they asked you, hey, what's that supposed to be? You'd be like, yeah, that's easy. Correct. Yeah. But if they just said, hey, this is that angle, you could just set 17x minus 3 into equals 90. You're correct. All right, so because they're congruent, we know they are equal. So we just set up that equal relationship. 17x minus 3 equals 9x plus 13. Okay. We're going to subtract 9 from both sides. Because what's our ultimate goal when solving these linear expressions?
You mean the exponent line?
Isolate that variable. Yep.
X equals 2.
So 9x minus 9 is 8.
And then you add the 3 and you get 16. And you 8 divided by 16.
We'll pump the brakes, senor. So x isn't quite isolated, so we're going to add 3 to both sides. Yep. Oh, no. And x equals 16. Divide by 8. And like all our quick jumping folks said, x equals 2.
I think I need to be in the honor.
Find the length of RS. So now we're not just finding the value of x. Once we find x, we've got to plug it back in to find the length of RS.
One of those was on the quiz,
Yes.
and I didn't read it fully,
Yes.
and I got it wrong.
Yes.
I just put what X equals.
Yes, because Coach Oliver's evil and will put the wrong answer in the multiple choice thing.
And yeah, you did do that too.
I did.
The real answer was 8.
How dare I? He's mean. I can't believe that guy's allowed to be a teacher. Because the right answer was there, but the wrong answer was also there.
Or no, 8 was C. No. Yeah. No.
Oh, wait, Coach, I have a question. Will you give us the distance formula on the test?
Yeah.
Oh, okay. We chilling then.
All right, so find the length of RS. We've got a perpendicular bisector. So what does that mean about RQ and RS? They're congruent. As long as that's a perpendicular bisector, that is a congruent relationship.
It's 9.
Okay.
Then you plug it back in.
Okay. So if they are congruent, how do we set up our equation?
To each other.
Set them equal to each other, absolutely. 7x minus 22 equals 4x plus 5. Oh, my pen exploded. Yeah, you didn't see it? I don't know. We're going to subtract 4x from both sides. 3x minus 22 equals 5. What do you want to do next?
No, you can't do that.
We divide both sides by 3, so x equals 9. But we are not finished because it doesn't want to know what x is. It wants to know the value of RS.
RS equals 41.
So we've got to take the value we found for x and substitute into the length of RS. So we substitute 9 into the value of RS that was given to us. 4 times 9 is 36. And then 36 plus 5 is 41. So that was our perpendicular bisector theorem. Now we have a bisector theorem. What's it mean to bisect an angle? That's in half. One more time. Yes. So if a point is on a bisector, then that point is equidistant from the sides of the angles. It's almost the same rule. Okay, so if AD bisects our angle, how do we know if it bisected it? How do we know that it cut it in half? What tells us that?
An equal angle.
How do we know the angles are equal? The hoops. The hoops. Hoop, there it is. We've got hoops. We've got perpendicular relationships outside. There's a lot getting thrown at us. As long as that's bisected, AB is perpendicular to BD. AC is perpendicular to CD. If that's true, then BD is congruent to DC. BD is congruent to DC. So that would be this segment is congruent to that segment. Which triangle congruence theorem would this one match? So we've got a congruent angle, a shared congruent side, and a congruent angle. Which theorem do y'all think? Almost. Well, I need two sides for that. I've got two angles and a side. Why angle, angle side and not angle, side, angle? Why angle, angle side and not angle, side, angle?
Because it's HL.
It's not HL because we got two congruent angles. A perpendicular B and then reflexive side, what is that, AD? Does the congruent side, in this case it's AD, does that congruent side touch both of our congruent angles?
Yes. No. No.
How do, when we look for congruence, how? When I look at one triangle at a time, does that congruent side touch both of my given congruent angles? No. One triangle at a time. Does that congruent side touch both of my given congruent angles? Yes. So it is angle, angle, side. And if you really want to get creative, how many A's does our S touch? In our picture, how many congruent angles does our side touch? And the converse, what's it mean to be a converse?
Flip.
What do you mean flipped?
Opposite.
What do you mean opposite?
Not the same as the other one.
It is the same.
No, it's just flip.
What's flipped?
Everything.
Nope. Hypothesis and conclusion. So we just take it from being, hey, the angle's congruent, so that side's got to be congruent. Now we're going to say the side is congruent, so what do you guys think the answer is going to be?
Congruent.
What's congruent? The angles. So so on the converse, if they tell us those bottom segments are congruent, now we're going to go with AD, which is a ray, bisects angle A, which creates what? If AD bisects angle A, what does it create? Nope. Two congruent angles. So if it is a bisector, it is going to create two congruent angles. So get specific and name those for me. Angle BAC is congruent to who? What do you think?
CAB.
Close.
Yeah.
CAD. BAC is congruent to CAD. All right, number 8. Find the value of X. So I've got an angle being bisected. I've got perpendicular outside relationships. So what do we know is true about those two segments? They are congruent.
They're equal to each other.
So we can set them equal to one another. So 4 plus 30 equals 9x minus 5. And then we're just solving for x again. Subtract 4 from both sides. Yep. 4x from left. 4x from the right. So we get 30 equals Plus or minus. Did I mess up? Yep, we're going to divide both sides by 5. So 7 equals x. Sure. Tomato, tomato, potato, potato. Let's call the whole thing off. I don't know what it's from. Number 9, we're going to find the value of x again. But this time we're using our converse. They said, hey, you've got these perpendicular relationships. And you bottom congruent segments. So what does that tell me about our angles up top? They are congruent. So we can label them with a hoop. Hoop, there it is. If they are congruent, we know they are equal.
Yes.
Yes. So we just set up our equal relationship. 5x minus 11
Equals 8x minus 41.
equals 8x minus 4. So we subtracted 5x from both sides. Now we're going to add 41 to both sides.
I just wrote the same thing.
That a boy.
Shoot.
So we get 30. Wow. Equals 3x. Oops, what happened? Divide both sides by 3. So x equals 10. I give it a 10. Number 12. So number 12, they hit us with a little different. Okay, so number 12 is a little different. It is. But they're going to reach back into our brains and challenge us. So when I look at this diagram, as it is given, they did not give me the criteria for the angle bisector because they didn't tell me that top one was congruent. And they did not give me the criteria for a perpendicular bisector. They did, however, give me something we've already learned. What's that? Well, it's not a straight line. I know about opposite sides in congruent triangles. If my opposite sides are congruent, what does that mean about their angles? They are also congruent. So they can reach back and they can challenge. That's almost CPCTC. And by almost, I mean it is. Because we can prove the triangles were congruent using hypotenuse leg. And then because my triangles are congruent, what do we mean about all the remaining corresponding parts? They are also congruent. So subtract 2x from both sides. I'm so glad I didn't throw this in the last unit. I thought there was plenty in the last one. Equals 3x minus 37.
X equals 19.
Wow. Add 37 to both sides. So 57 equals 3x. Divide both sides by 3. So x equals 19. But that's not what it wanted. It wants the value of angle FGH. How am I going to find that full value? I've got a couple ways I can get after it. I could plug it into both, or I could plug it into one and multiply by 2. It'll work either way. So let's find the measure of angle FGI. The measure of angle FGI is 2x plus 20. Does everybody see where I got that from? So FGI. That's this angle right yonder. I could have also used HGI. We're going to substitute our known value of x, which is what? So we're going to plug in 19 into our equation. Two times 19 is 38. Right? Right? Plus 20? 58. But that's not what it wanted, right? That just tells me that this angle is 58 and the other angle is 58. So how could I find the measure of FGH? I could add them together, or I could multiply by 2.
Yeah.
So 2 times 58 is 116.